Okay, the last rule that I'm going to go over is the rule of definition for the biconditional. Biconditional isn't really a separate logical connective. Um, it's a shorthand, an abbreviation for two conditionals. So that's why it's called biconditional. So basically, the biconditional P if and only if Q um, is P arrow Q and Q arrow P. Here, the P arrow Q and then Q arrow P, it sort of represents the double direction for the biconditional. And so the rule of definition basically says from the one you can go to the other, from the other you can go to the one. Sort of like an abbreviation or a definition. So the rule of DF allows you to go from one to the other. Right. And so let's use this rule to work with a proof. I guess we can work with a simple one. What we're going to do is A, okay, if A, or A if and only if B, therefore B. Okay, so we have two premises to work with, and we have to derive a simple formula. I'm going to need more space. Okay. As you can see, what we have to do is derive B, and we don't have a rule that extracts B out of this. Right? This turns into something like this. And so what you could do, right, is break this down, right, to the bigger formula, A arrow B, and B arrow A, right? That's going to be from 2, DF. That's an F. Yep. Okay, so this is 2. And then on 4, right, since this is now a conjunction, we can pull either one of these out. So it looks like the one that's going to be the most useful is the one on the left, right? So A arrow B, we can extract from 3 and elimination, right? And that will just come from 2. Right? And then on line 5, what we can do now is use 1 and 4 to get B, right? And we can get this by applying the rule of conditional elimination. And then our dependency numbers will be from 1 and 4, which is 1 and 2. And there you go. We've just derived B. So that's a pretty straightforward example for the biconditional. The biconditional makes the proof a little bit longer, but it's pretty straightforward to use. What we didn't see an example of is sort of the opposite direction. So if you have something like this on a line where you have the two conditionals and the one goes to the other and then the other goes to the one, you get to sort of form a biconditional, make a shorthand out of this long formula. So that's all the rules we'll need to know for the language of sentential logic. And so from there we can do all of the proofs. So this is just the basic review of the rules. I'll go through the strategies and, of course, how to calculate dependency numbers in the next videos.